Welcome to 3.2 three-variable systems. Today we're going to solve a three-variable system of equations using substitution. So I'm going to walk you through the first example and then we will kind of just pick up the steps on the rest of the problems. So for our example one, first thing you're going to want to do is solve for one variable. And this one's pretty easy because we already have z is equal to 4. Then you're going to want to use that value and plug in the variable into the next equation. Now, this could be in a different order. You're just going to kind of figure out how to work your way up. So I have y plus z equals 7. I'm going to plug in my z value of 4, and then I'm going to solve for y by subtracting 4 from both sides and getting y equals 3. Now I'm going to do the same thing plugging into my next equation, plug in variables into the next equation, and I'm going to get x plus 3 plus 4 equals 12. The 3 is the y value, the 4 is the z value. And when I solve this, I get x equals 5. And the last step is going to be write your answer as an ordered triplet, meaning you're going to have to write it in alpha order, x, y, z, 5, 3, 4. Okay, looking at example 2, I'm going to follow similar steps to what I did for example 1. I'm going to solve my last equation for z. I'm going to divide both sides by 3 to get z equals -1. I'm going to use this -1 value to plug into my second equation. So I end up with 2y minus -1 equals 7, which is 2y plus 1 equals 7. I'm going to subtract 1 from both sides, giving me 2y equals 6. Divide by 2 to get y equals 3. Now I'm going to use y equals 3 and z equals -1 to plug into my first equation, which is going to give me 2x minus 3 plus 3 -1 is equal to -2. Simplify this a little bit to get 2x minus 3 equals -2, which simplified even more is 2x minus 6 equals -2. Going to add 6 to both sides, giving me 2x equals 4. Going to divide by 2, getting x equals 2. And my last step is always going to be writing my answer as an ordered triplet, 2, 3, -1. Now, example 3 is a little bit different because I don't necessarily have one variable that is very easy to solve for. So I have to do a little more manipulation than I have done in my previous examples. The first thing I want you to notice and see is that I have x plus y in two equations. Now, this is something I can use so that I can replace one of these so that I have one variable in one equation. So the first thing I want to do here is I want to get x plus y by itself in this last equation. So I'm going to add z to both sides. So now I have x plus y equals z. So what I'm going to do is I'm going to take this statement, and where I see x plus y in my first equation, I'm going to replace it with z. So I'm going to end up with z, which is from this equation, plugged into my first equation, which has plus z equals 24. Now I only have one variable, which makes it so that I can solve for that particular variable. I get 2z equals 24, and I get z equals 12. Now I want to solve for another variable. So say, for instance, I want to solve for y. That means I want to get one equation completely in terms of y. So what I'm going to do is I'm going to first take my original first equation and I'm going to plug in my new z value. So I get x plus y plus 12 equals 24. So then I'm going to get x plus y equals 12 when I subtract 12 from both sides. And then I'm going to solve for x. Now, the reason why I'm solving for x is so now I can take this statement and replace any x that I see with a y variable equation. So I'm going to do this to the second equation. So I'm going to plug in for the x value, because it was 5x, Now it's 5 times negative y plus 12, which is from this statement, plus 3y. I want to deal with y's, so I'm going to leave that alone, plus 12, which is my z value, equals 56. So I'm going to distribute this 5 to give me negative 5y plus 60 plus 3y plus 12 equals 56. And now it's just solving. I'm going to subtract 72 from both sides because 60 plus 12 is 72. And I get negative 2y equals negative 16. Going to go ahead and divide by negative 2, which is going to give me y equals 8. Now, the only thing I have to solve for is x. You really could pick and choose whatever you wanted to do. I actually went into my first equation again and plugged in x plus 8 plus 12 equals 24, which gave me x equals 4. And now my final answer is going to be 4, 8, 12, an ordered triplet. Now moving on to writing equations and solving them from word problems. So I have example 4. The sum of three numbers is negative 4. The second number decreased by the third is equal to the first. The sum of the first and second number is negative 5. Write a system of equations to represent the following situation and find the product of the three numbers. So the first thing I'm going to do is define my variables. I am letting x be the first number, y be the second number, and z be the third number. And now I'm going to go in and write my system of equations. So I'm going to break this down sentence by sentence. So the first claim I have is that the sum of three numbers is negative 4, and the sum is the addition. So I'm going to say x plus y plus z equals negative 4. Then I have the second number decreased by the third is equal to the first. So that is the same statement as y minus z equals x. And my last statement is the sum of the first and the second number is negative 5. So x plus y equals negative 5. Now I'm going to go ahead and solve the system. So the first thing I'm going to do is notice again that I have this x plus y statement in two places. And this one's already solved for a number. So all I'm going to do is take this negative 5 and replace this x plus y with it. So I'm going to get negative 5 plus z equals negative 4. Going to add 5 to both sides, which is going to give me z equals 1. Now I'm going to solve for y. I'm going to go into this equation and I'm going to rewrite it so that it's x equals y minus 1. And then I'm just going to plug y minus 1 into this x. So this x is going to go away. It's going to be replaced with y minus 1. So y minus 1 plus y equals negative 5. If I simplify this, it gives me 2y minus 1 equals negative 5. Going to add 1 to both sides to give me 2y equals negative 4. Divide by 2 gives me y equals negative 2. Then all I have to do is I can take this negative 2 and plug it back into that equation I rewrote. Gives me x equals negative 2 minus 1, which is x equals negative 3. Now, typically with word problems, you will have some type of solution that you are looking for. We do not write an ordered triplet for word problems. So this time we're going to answer the question, and the question was to find the product of the three numbers. So negative 3 times negative 2 times 1 is equal to 6. And for our last problem, we have the triangle has a perimeter of 65 feet. What are the lengths of sides L, M, and N? If your variables have already been defined, so we have clearly defined sides, you do not have to go in and restate the variables. So I'm going to leave it as L, M, and N. And a perimeter means the sum of the side lengths. So L plus M plus N must equal 65. So now we have to do a little bit of solving. So I notice that I can get all of my side lengths to be in terms of M. I already have L is equal to 1/3 M. And I can take this and replace it into side n. So I'm going to rewrite this so that it's n equals 1/3 m, because I'm just plugging this in for L, plus m minus 15. Now all of my side lengths are in terms of one variable. So I'm going to use my perimeter equation and replace L and replace n with the actual rewriting. So I have 1/3 m coming from the L side length plus m plus 1/3 m plus m minus 15, which is side n, equals 65. Now, to make our lives easier in combining the m's, I'm going to rewrite my 1 as 3/3. So remember, when you're adding fractions, you're just going to add the numerators when the denominators are the same. So 1 plus 3 plus 1 plus 3 is going to give me 8/3m minus 15 equals 65. I'm going to add 15 to both sides, which is going to give me 8/3m equals 80. Now to solve for m, I'm going to use the reciprocal 3/8, because 3 times 8 is 24, divided by 8 times 3, 24 is just 1. Now remember, numerator times numerator, denominator times denominator. If I don't have a denominator, I assume it's a 1. So this turns into 80 times 3 is 240/8. So I get m is equal to 240/8. And when I simplify this, I get m equals 30 feet. And all I have to do is use m to plug back into my side length L equation and n equation. So let's solve for L first. 1/3 of 30 is 10 feet. And n, I'm going to plug in the 10 from the L, the 30 from the m, and get n equals 25 feet.